Hey everyone, I hope you're doing well today. In this video, I'm just going to be making an answer key for the Unit 1 Homework 8. So hopefully this is helpful. I know having the answer key can help with just identifying where you might have made a mistake here or there and find out why you might be doing something right or wrong and how you can learn from your mistakes. Whoops. But also, I thought maybe a video answer key will help as well, so you can kind of see the process written out. All right, so we're focusing on fraction work here. So let's go ahead and get started. All right. Go ahead and I'm not really going to edit too much here. You can see everything I'm doing. For number one, we are dealing with some sort of triangle and it has three lengths. So I'm just going to go ahead and draw a triangle here. It doesn't really matter what you label what, but one side of this triangle is going to be 3/4. That's going to be one length of it. One side is 1 2/3. Again, I didn't draw anything to scale, so don't worry about that too much. And the other one is going to be, whoops, I think that's going to be 2 1/2. Okay, and these are all going to be in inches. So to find the perimeter of this thing, we're going to have to add everything up. So to find the perimeter, it's just going to be adding up this 3/4, that's one side, plus the 2 1/2, which is another side, and then add on the 1 2/3, or the third side. Okay, so there's a few different ways to go ahead and do this. How I'm going to go ahead is I'm just going to turn everything into an improper fraction or proper fraction first. So 2 times 2 is going to be 4 plus 1 is 5. So we can rewrite 2 1/2 as 5 halves. And then for this 1 2/3, let's go ahead and do 1 times 3 is 3 plus the 2. That's going to be 5/3. Okay, so there you go. You have 5/3. We got to take a look at this denominator and notice that we have uncommon denominators, so we can't really add these fractions together right now. If you want to find out where 4, 2, and 3 meet for the first time, you can use the ladder method, or you can do it in your head, or you can use prime factorizations. 1 is their GCF, so you can't go put anything into all three of them, but if you just look at two of the numbers for the LCM, 2 goes into 4 twice, 2 goes into 2 one time, and this 3 is not being used, so it just comes on down. And what you can do is you can go ahead and multiply these outside numbers, and that gets you the LCM, or the least common denominator. So by multiplying those numbers together, you're going to find out that the least common denominator is going to equal 12, and that's the first time they meet. So to get to 12, we're going to multiply this by 3, multiply this by 3, multiply this by 6. 2 times 6 is 12. 3 times 4 is going to be 12, and multiply by 4 up here as well. Okay, so the new fractions here, this 3/4 is equivalent to 9/12. This 5 halves is equivalent to 30/12, and then 5/3 is equivalent to 20/12. So again, when you're adding and subtracting fractions, you need common denominators. So now that they all have a 12 on the bottom, sorry, my dog is shaking a little bit there. We're going to go ahead and add these together. So 9 plus 30 plus 20, that's going to equal 59 all over 12. And if we want to convert this into a mixed number, we can just do some long division and say, okay, how many times does 12 go into 59? Goes in 4 times, I think. That's going to be 48, and the remainder here is going to be 11. It was just one shy. So we can also say this is going to be 4 11/12 inches. All right, so that would be all the way around this triangle. That would be the perimeter. All right, so there you have number one, okay? Just a little bit of addition work, but an application to geometry, okay? A little bit more applicable when we try it with a scenario. For this next one, I'm gonna go ahead and draw this out. So they say we have a rectangle, whoops, there we go, there's a rectangle. And just keep in mind rectangles have 4 sides, and we have, what dimensions do they tell us here? They say 3 5/6, I'll put that along the longer side. And then 2 3/4, I'll put that along the shorter side. All right, so even though you're only given 2 measurements there, just try to keep in mind that the top is going to be the same. So this is also 3 5/6. Some people might forget about that one. And then 2 3/4 is going to be the side to the left. Okay, so to find the perimeter, how can we go ahead and do this? Well, the formal formula, I guess you can use here, is twice the length plus twice the width, right? And so if I call this the length over here, and I call this the width, that should make it a little bit easier to kind of recognize what we're doing. And so let's see, we have the perimeter is equal to 2 of the lengths, 2 times this 3 5/6. You could add 3 5/6 to itself, or you can multiply it by 2, whichever one you're more comfortable with. And then we have 2 of these widths. So 2 times 2 3/4. Okay, so maybe to kind of clarify this a little bit as well, this is the length and then this is the length we're talking about, and this is 2 of these, okay? And then also to kind of show you the other one, the width over, whoops, that is not a highlighter. The width here is 2 3/4, so that's the 2 3/4 over here. And so let's see, we have the perimeters equal to, I won't keep writing, P is going to be 2, which is 2 over 1 as a fraction, multiplied, and let's turn this 3 2/5 into an improper. So 3 times 6 is 18, plus 5 is 23. So that's going to be equal to 23 over 6 plus, and then we have 2 over 1 multiplied by this mixed number. And so let's turn it into an improper. So 2 times 4 is 8, 8 plus 3 is going to be 11. So that's going to be 11/4. Okay? We can go ahead and multiply these fractions together. Just looking at this fraction to the left, multiplying 2 of these things together. Well, you can cross cancel and make this a 1 and make this a 3. That's just a little bit of simplifying along the way. So I think that's all we can do. So 1 times 23 on top is going to be 23. And on the bottom, 1 times 3 is going to be 3. And then for the next set of fractions we're multiplying here, we can say this 2 and 4, we can simplify, divide those both by 2, or their GCF, that's 1 and 2. And so 1 times 11 on top is 11, and then 1 times 2 on bottom is 2. All right, so there you have products of those two are twice the length plus twice the width. And if you didn't feel comfortable with multiplying, you totally can just divide. Not divide. You could just add them twice instead. That's totally okay. All right. This 2 and 3 are not common denominators, so we need to find when 3 and 2 meet for the first time. I know you could probably, some of you do in your head, but I'm just going to go ahead and write it out. 1 is their GCF. So then if you multiply 1 times 3 times 2, you get the LCM or LCD. So I'm just going to write everything out to be super clear. If it helps anybody a little bit more, that's the goal. So how to get to 6, multiply 3 by 2. How to get to 6, multiply 2 by 3. All right, so going ahead and doing so, we should see the next line here. 23 times 2 is 46. And feel free to use a calculator if you need one. And then 11 times 3 is 33. And then 2 times 3 is 6. Okay, so now that we have these common denominators, we're allowed to add these fractions together. And so let's see, 46 plus 33, I think that's 79. So 79 over 6. And we have to convert this to a mixed number. So let's see, 79, let me see how many times 6 goes into that. Goes in once, that's 6. That's going to be a remainder of 1, that's a 9. 6 into 19 3 times, that's 18, remainder 1. So to write our final answer here, the perimeter of this figure, of this rectangle, would be 13, because it goes in 13 times, and 1/6. And I think our units are centimeters, so I'm going to write cm for centimeters. That would be our solution for number 2. That's the perimeter of a rectangle. Okay. Let's see what we got here. Okay, running out of space, so I'll go over here. For number 3, let's check this out. We have a square. Let's go ahead and draw one of those. Okay. And this square is going to have a length of 2 2/5 meters. And if it's a square, just keep in mind that all the sides are the same. So you can add 2 2/5 plus 2 2/5 plus 2 2/5 plus 2 2/5. That's totally one way to do it. Or you could just take 2 2/5 and multiply it by 4. So I think that's what I'm going to do. I'm going to say we have 4 multiplied by 2 2/5. Again, feel free to add 4 of them if you would like, but I'm going to multiply. Okay, so 4 as a fraction is 4 over 1, and 2 2/5. So 2 times 5 is 10, plus the 2 is going to be 12. So that's going to be 12 over 5. Unfortunately, we can't do any cross-canceling here. 4 and 1, 4 and 5, 12 and 1, 12 and 5, they have nothing in common. So 4 times 12 is going to be 4 times 12 is going to be 48 on top, and then 5 on bottom. 1 times 5 is 5. To turn this into a mixed number, let's take our 48 and divide by 5, just writing this out to be super clear. 9 times 5 is 45. That's as close as we can get. We'll have a remainder of 3. So we're going to have 9 3/5, and that would be the perimeter all the way around, and we're measuring this in meters. Again, if you're still not comfortable with multiplying, that's okay. You can totally just add up the 4 sides, and that will also work. Okay, that's number 3. Moving on to number 4, let's see, we have a rectangle. Okay, this one's similar to number 2. Okay, so let's go ahead and set up a rectangle here. And let's see, the base is 5 3/8, so it's the longer one, 5 3/8. And the height is 2 1/4. So I know you probably know this, but I'm just going to label these up here to remind you in case you might forget to use these measurements as well. And we're going to go ahead and see if we can find the perimeter here of this rectangle. So I'm actually going to move this over a little bit so I can maybe put the work to the right. So to find the perimeter of this thing, again, we have 2 of the lengths plus 2 of the widths. This will be my length, and this will be my width. Okay, so I think the colors I used, I don't remember actually, but let's call this the length. I guess look here. Yep, same color. And the width, we'll call it 2 1/4. Put that right over here, same thing. Okay, so let's see. Let's do twice of the length. So we'll do 2 of these 5 3/8 because there's one on top and one on bottom. Plus, let's find 2 of these 2 1/4. Okay, so again, the widths are going to be represented here. That's the 2W, 2 of those. And then for the lengths, we have 2 of these, and then we have 2 of those. Okay, turning these into some improper fractions. 2 is just 2 over 1. 5 times 8 is 40, plus 3 is 43. So that's going to be 43 over 8. And then plus 2 over 1 times, and let's see, 2 times 4 is 8, plus 1 is going to be 9. So that's going to be 9/4. Okay. If we go ahead and multiply these out, let's go ahead and just look at this product here, 2 of those. We see we can cross cancel. The 2 and 8 is going to be 1 and 4. And then if we multiply 1 times 43, that's 43. And then 1 times 4 is going to equal 4. And then for multiplying these two fractions, or the 2 widths together, 2 and 4 are going to cross cancel to make 1/2. And on top, 1 times 9 is going to be 9. And on the bottom, 1 times 2 is going to be 2. So we would like to add these fractions together, but unfortunately we don't have common denominators. So 4 and 2, where do they meet for the first time? Hopefully this one's a little bit more clear, but they meet at 4 for the first time, so I'm not going to use the ladder method to show that. So we can rewrite this as 43 over 4 plus, and then 9 times 2 is 18 over 2 times 2, which is 4. Now that we have these lovely common denominators, we can add 43 plus 18. And 43 plus 18, I think, is going to be 61. So that's going to be 61 over 4. And turning this into a mixed number, you can totally take 61 divided by 4. I'm sure it's 15 and 1/4, but I'll write it out in case it helps anybody. So that's going to be 15, that's 20, remainder of 1. Okay, so our final perimeter here is going to be 15 and 1/4. What kind of units do we have? I think we have feet. Yeah, feet here. Oops. And this would be the perimeter of this rectangle. Okay, so again, if you're not comfortable with multiplying, it's okay. You can totally add the 4 sides together, but I'm just kind of bridging both concepts together here and seeing if you can kind of try this as well. That's ultimately probably the best way or the most efficient way to solving these types of questions about perimeter. Okay. Moving on to number 5. Number 5. Let's see. Determine the product of each of the fractions by multiplying first, then simplifying second. Okay, so this is kind of the most basic way of multiplying fractions before you learn about cross-canceling and things like that. So let's just take this 7/10 and let's multiply that 15/7. Okay, so if you don't know about cross-canceling yet, or even if you do, just try to be patient here. We're just really, again, multiplying the tops together and then multiplying the bottoms together. And so 7 times 15, again, I'm okay with using a calculator here. That's 105, and 10 times 7 is going to be 70. Okay. At this point, we've practiced using the ladder method for simplifying, so I think that's what we're trying to practice of just making sure we can do that. So 105 divided by 70. What common factors can we think of? A lot of people think of 5 first here by divisibility rules. Then when you do that, I think this is going to be 21. And then 5 goes into 70 14 times. And then you can look at these two numbers and say, okay, I think 7 is a common factor. That would be 3, and then that would be 2. Okay, so how can we write our final answer here? Well, you should be able to then take this ladder method and say, okay, this, what color should I use here? I'll use this. I think I've used it in the past for GCF. GCF here is going to be 35 because 5 times 7, so they're both divisible by 35. And then when you do that, you end up getting this simplified fraction of 3 over 2. And then as a mixed number, that's going to be 1.5. All right, so both of these would be fine for a final answer here, especially because it's not a word problem. And that would be that. Okay, that's number 5. Whoops. Let's try number 6 here. For number 6, we have 15 over 18. And we're going to go ahead and multiply that by 12 over 30. So we'll go ahead and multiply 15 times 12 on top, and we'll multiply 18 times 30 on bottom. Okay, so 15 times 12 on top, I think that should get us 180. Okay, and then 18 times the 30 on bottom, I think that's 540. Okay. Now to simplify second, if you'd like to, you can always cross off these zeros. That's basically just saying we're dividing both by 10 on top and bottom, which is a common factor. And then that way you can kind of use smaller numbers when you're using this ladder method. If you take a look here, I think a common number people think of here is maybe 9. 9 times 2 is 18, and then 9 times 6 is 54. And then looking at 2 and 6, 2's in common, so the final fraction here is just 1/3. Again, if you look at these side numbers, the GCF would be 18 for what we have left here. So you can divide this by 18 and divide this by 18. And then, let's see, that would just be 1/3. And since that's a proper fraction, you know, that's it. We don't have to do any other versions of it. All right, that's number 6. For number 7, let's see, we have 21 over 20, and we're multiplying this by 10 over 28. Okay, so we're going to multiply 21 times 10 on top, and then we're going to go ahead and multiply 20 by 28 on bottom. And 21 times 10, that should just be 210 on top. Just add a 0 onto 21. And then 20 times the 28 on bottom, that should be 560. Let me move this up here. Again, when they both end in zeros, just divide them both by 10, and that's perfectly fine. Nice little shortcut. And then 21 and 56. We got to think of a common factor. I think 7 times 3 is 21, right? And then 7 times 8 is 56. So our GCF here that we have left is going to be 7. So divide this by 7 and divide this by 7. And so we can see here that 21 divided by 7, or we can look at the final as well, is just 3/8. But if you check the division, it also works out. Okay, there you have number 7. Okay, let's move on to number 8. I'm going on to the next page here. Number 8. Let's try multiplying this 1 3/4, multiplying this by 8. And when we do so, we'd like to go ahead and write them as improper fractions. So 1 times 4 is going to be 4, plus the 3 is going to be 7. So we write 7 over 4. And writing 8 as a fraction, that's just 8 over 1. Okay. On top, 7 times 8 is going to be 56. And on bottom, 4 times 1 is 4. And let's see about simplifying this thing here. So, well, we have 56, and 4. And you can use a calculator if you're not sure, but you can divide them both by 2. I think that's usually what a lot of people would probably start with. I would start with 4 personally, but I think it's maybe helpful to see what maybe most people would do. And then 2 again, and that would end up being 14 over 1. So it's a whole number, right? If it's over 1, that means it works out nicely to being a non-fraction. So divide this by 4 and divide this by 4. And get rid of this equal sign. I think earlier I was putting them over here. And that would just be 14 over 1. And that simplifies down to 14. And there you have how to multiply fractions, just like that. Okay. And again, we're just multiplying first and dividing second. We're just practicing and using these strategies. But again, there's many ways to do it, I'm aware. And we'll practice using the other strategies in a little bit. Okay. For this next one, what's 9 as a fraction? Well, 9 as a fraction is going to be 9 over 1. And then this 4 and 5, 6, that's 4 times 6 is 24, plus 5 is going to be 29. So that's going to be times 29 over 6. Okay? And so go ahead and multiply 9 times 29. Well, 9 times 30 is 270. Take away a 9 is 261. And on bottom, we just have 1 times 6, or 6. Okay. Simplifying here, let's see. 2 plus 6 is 8 plus 1 is 9. Oh, okay. So using our divisibility rules, we know we can divide these both by 3. Okay, so we can put a 3 over here. Again, you can use a calculator to divide this by 3. That's fine, or use long division. That's going to be 87 over 2, and I think that's as far as you can go. So we can go ahead and say we can divide this one by 3 and divide this one by 3. And if we do that, we would end up with 87 over 2. Okay. In terms of turning this into a mixed number, you can take half of it. I'm just going to show the long division here. Don't know what happened with that 2. That would be 4. That's going to be 8. Subtract. That's going to be 0. Bring down the 7. 2 goes into 7 3 times. That's going to be 6. And there's a remainder because we have an odd number here. So this would equal 43 and a half. That would be our final answer here. Okay. Let's go on to number 10. Last one of this section. If you don't like this method, sorry, but just a few of them. They're not too bad, and I hope and it makes sense, ideally, that we're just kind of using and building on some foundational things we've been practicing. Let's go ahead and turn these into improper fractions. So 4 times 4 is going to be 16. 16 plus 3 is 19. So we have 19 over 4. And then 3 times 3 is 9, plus 1 is going to be 10. So that's going to be 10 over 3. Okay. On top, 19 times 10 is going to be 190. And on bottom, 4 times 3 is going to equal 12. Okay, so little ladder method here. 190 and 12. What can we divide these both by? We can divide them both by 2. It's the first thing that comes to my mind. I think 95 would be half of that, and then 6 would be half of that. 6 can be divided by 6, and 6 can be divided by 2 and 3. 9 plus 5 is 14. Can't divide by 2 because it's odd, and 14 is not a multiple of 3. Okay, I think that's it. So 2 here is the GCF of what we have here. So divided by 2 divided by 2. And that's going to equal 95 over 6. As a mixed number, hopefully you're just kind of getting the patterns down. Dividing this by 6, that's going to be 1 times 6 is 6. That's a remainder of 3. Bring down the 5. This goes in 5 times 6. That's 30. And the remainder is 5. So this whole thing goes in 15 times with 5 6 left over. Again, the improper fraction's fine for these, again, but I think it's better to practice converting to mixed numbers just to make sure we have that skill down and we can do it quickly. So with practice, it gets a lot faster over time. Alrighty, so let's move on to number 11. From number 11 on, we are not going to multiply first, we're actually going to simplify first. So we have this 15 over 24, and we're going to multiply that by 18/30. Okay, so a couple ways to do this. I'll start off by kind of showing you the prime factorization method, which is where you just take each of the values and just kind of break them down first. So let's go ahead and try that, and then I'll show you the cross canceling. Okay, so if we take a look at this 15, 15 really breaks into 5 times 3. Those are its prime factors. We can go on to looking at 18 here. 18 breaks into 9 times 2, but 9 breaks into 3 times 3. So we have 3 times 3 times 2. Moving on to, let's choose color I have in writing here. 24 is 6 times 4. 6 is 3 and 2, but then the 4 is 2 and 2, so that's 24 represented in prime factors. And then finally, let's look at 30 here. 30 is 6 times 5. 5 is prime, but 6 is 3 times 2. All right? So there you have the prime factorization of this product here. And what we can do is we can actually just cross out common primes or common factors on top and bottom. So 5 and 5 cancel out to make one whole. We don't need to write it. 3 and 3. What else we got? 3 and 3, and then 2 and 2. So when we write our final product here, we just look for the leftover prime. So in the numerator, we have this 3. So we can go ahead and say that's going to be 3 in the top or in the numerator. And on the bottom, we have a 2 times a 2. That's a 4 times a 2, and that's an 8. So there we have 3/8 would be the final solution here. Okay, that would be the answer or the product of this multiplication problem. Showing you this problem again, but by cross-canceling instead from the original numbers and not using prime factorizations, what you can do is, let's say, pick two numbers top and bottom that you have a common factor. So if I was looking at this, maybe I'll use this color, 18 and 24, you can divide them both by 6. And if we divide 18 by 6, we would get 3. And if we divided 24 by 6, we would get 4. Similarly, we could go ahead and say 15 and 30. You can actually divide them both by 15. The 15 divided by 15 is 1, and then 30 divided by 15 is 2. If you didn't see 15 on the first try, you could start with 5, then use 3 after, or you can use 15 at once if you see it, okay? 1 times 3 on top is going to be 3. And on the bottom, this 4 times 2 gets you the 8. So this is the quicker way to do it, obviously, but sometimes it's easier to see the prime factorizations. It's a little bit more visual to see all the pieces, but this is another nice way to go about solving this. Okay, so there's number 11, and let's try another one. Okay, each time I'll try them both ways just to help you feel a little more comfortable with it. So for 12, we have 25 over 36. We're going to go ahead and multiply that by 27 over 30. Okay, so let's see how everything breaks down here. All right, so 25, that's 5 times 5. Go ahead and write that up here. And moving over to 27, well, let's see, that's 3 times 3 times 3, that's 27. On the bottom left, we have this 36. 36 is 6 times 6, but each of those breaks into a 3 times 2 and another 3 times 2. And we have one more number here. We have 30, which is actually the same 30 we had earlier in the bottom right. And so we know that's 5 times 3 times 2. Okay. Now we're just going to cross off some common values. So 5 and 5 are the same. I don't think there's another 5, but 3 and 3 are going to be the same. We have another 3 and another 3 that are matching, and I think that might be it. Okay, so on the top, or in the numerator, on the top, multiply this 5 and 3 together, that should be 15 in the numerator. And on the bottom, let's see, we have 3 times 2, that's going to be 6. 6 times 2, it's going to be 12. Oh, actually, I noticed something that I forgot, just because I noticed we had an extra 3 there. So check out this 3 and this 3. Those can cancel out, right? So let's see. That's going to make it a little bit easier. 5 is just going to be on top. On the bottom, we have 2 times 2, which is 4 times 2 is going to be 8. So there you have 5/8. Good thing I caught that extra 3. It wouldn't have been bad. I just would have had to simplify and divide by 3 afterwards. Okay. Here's solving this one more time. The same problem, but using slightly quicker method. We're looking for common factors, anything. It could be bigger than prime numbers, which is nice. So divide this by 9 and this by 9. We'll get 3, and then we'll get 4. And then 25 and 30, you can divide them both by 5, and to get 5. And if you divide 30 by 5, you get 6. Okay. Then we can go again, 6 and 3, or 3 and 6 rather. Those simplify down to 1/2. Again, 3, 6 is the same thing as 1/2. And then on top here, we have 5 times 1. That's going to equal 5. And in the denominator, we have 4 times 2. And that's going to equal 8. All right, so again, either way, it matches. And it's nice. I feel pretty confident my answer is correct because I just solved it 2 different times. And I got the same answer both times. Okay, let's try another example together. So here's number 13. For number 13, what do we have? We have 18. I'm going to multiply that by 5 and 7/9. Okay, so we have a whole number and a mixed number. No worries. Let's see what we got here. 18 is going to be 18 over 1. So I'm going to write the 1 on the bottom just for consistency. For 18, let's break that up into 9 times 2. But, oops, I don't know what's going on there. But 9 is 3 times 3, and then times 2. So that's the 18, right? And then for this 5 and 7/9, let's turn it into an improper fraction. 5 times 9 is 45, and 45 plus the 7 is going to be 52. 52 over 9, right? So how can I keep this pretty organized here to help everyone keep everything the same? So this is the 18 over 1, and then maybe I can use a different color here. for this 5 and 7/9. So I think we said it was going to be 52 over 9. Well, the 9 on bottom is going to be 3 times 3. That's where the 9 is going to come into play. And then for the top 52, 52 divides by 2, so that's going to be 26. 26 divides by 2, which is 13. So again, hopefully this helps you see where these came from, but 5 and 7/9 as an improper fraction is 52 over 9, and so I broke 52 down on top, and I broke 9 down on bottom. Okay. Now I'm going to go ahead and cross off some stuff. This 3 and this 3, this 3 and this 3. It's kind of nice. There's actually no more numbers on the bottom besides 1, so it's going to be a whole number, right? That's what we're basically going to get here. The 2 and 2 and 2 and 3, so I guess those didn't cancel out with anything, so I think the 13, sorry, is actually 52, and 52 times 2 is 104. 104, so this final answer is actually just a whole number of 104. Okay. Let's see if we can try this using cross-canceling. So if we were to just take this 18, again, this one's a little bit different. We have to write like 18 over 1, and then write this as 50, I think we said 52, right? Yeah, 52 over 9. And so what's nice about just using this method right away is 9 and 18, you can divide them both by 9. And so you would get 2 and you would get 1, right? So this is a lot more straightforward because 2 times the 52 is 104 right away. And on the bottom, this 1 times 1 is just equal to 1 right away. So we end up with 104 either way. And this second method, I like to think, is a little faster and a little less messy. You don't need to write all the prime factorizations out, okay? But whatever floats your boat. That was 13. Let's try 14 here. 14. For 14, we have 3 2/3. Let me go ahead and write it down. Actually, let me skip another line. Will I have enough space to fit it? Maybe not. All right, I won't be greedy. Let's move this up here. That should be enough space. All right, for 14, 3 2/3. Let's multiply that by 2 1/4. Okay. So I'll use the prime factorization method again here. Let's do 3 times 3 is 9. 9 plus 2 is going to be 11. So that's going to be 11 over 3. That's kind of nice. They're both prime numbers, so I don't have to break them down. And let's see what else we have here. 2 times 4 is going to be 8. 8 plus 1 is going to be 9. So it's going to be 9 over 4, but the 9 breaks into 3 times 3. 3 times 3. And the 4 breaks into 2 times 2. Okay, so again, let's see, I can label this as the 3 2/3 was the same thing as 11 over 3. And then if we take a look at 2 1/4, 2 1/4, that's the same thing as 9 over 4. And that's where that's coming from, okay? Trying to be super clear with that. And we have all our prime numbers. And so this will cross cancel with this. And I think that's it. Not a whole lot going on here. So on the top, 11 times 3 will equal 33 for the numerator. And on the bottom, we have 2 times 2, and that's going to be 4. And as a mixed number, 4 times 8 is 32, so it's 8 1/4. Okay, that would be the remainder. I'm not going to write out the long division right now to show that, but hopefully that makes sense. Doing it just by cross-canceling, again, you don't need prime factorization, so 3 times 3 is 9 plus 2 is 11, so it's 11 over 3, multiplied by 2 1/4, which is 2 times 4 is 8 plus 1, we said is 9 over 4. I forget really quickly, so just checking. Divide these both by 3, and that would be 1, and that would be 3. And so we have 11 times 3 on top, which would be 33. And then we have 1 times 4 on bottom, which would be 4. And as we said earlier, 4 goes into that 8 times with a remainder of 1. So we have 8 1/4. That would be the final answer here. Okay, that's 14. Let's try 15. Just a couple more examples of these. For 15, we have 5 2/3, and we're going to multiply this by 6 1/2. Okay, so let's turn these into some improper fractions so we can go ahead and write out their prime factorizations. 5 times 3 is 15 plus 2, and that's going to be 17, so 17 over 3. Those are both prime numbers, so I'll go ahead and write them right away. 6 times 2 is 12 plus 1 is going to be 13, so that'll be 13 over 2. Actually, those are prime as well, so we actually don't need this to be that long, and all our factors here are prime, so there's nothing much we can actually do. We actually can't cross cancel at all here. So a little bit of a bummer, because that's kind of like the fun part of multiplying these. And so let's see what we have. 17 times 13 on top. I think those are our leftovers, so I'll go ahead and circle them. 17 times 13, and that will equal, I think, 221. And on the bottom, 3 times 2, and that's going to equal 6. Okay. Is it divisible by 6? No, it's not. I know 6 times 36 is pretty close. 6 times 36, I believe, is 216, if I'm not mistaken. I just know that's 6 to the third power. So I think this is actually going to be 36. That's 216. I think it's 1 away, right? So it's 5, 6. 6 times 36 is 216. Yeah, I think that's right. Okay, so should be good. Okay. Yeah, that's it. So you're going to notice here that if you use the other method, it's not much better, right? Because everything's prime. So 17 over 3 would be the improper, times 13 over 2, which is the improper version. And again, like these, nothing cancels out. You're just left with 17 times 13. That's going to be your 221. And then 3 times 2 is going to equal 6. So nothing really, both methods are about the same in this case, right? 36 and 5, 6. Whoops. Let's see if I can make that. There we go. There's 15. And here's one more multiplication question to practice these new strategies, or if you've already known them, great, then it's just a little bit of review for you and some extra practice. So we have 7 and 4/5. Let's multiply that by 15. And let's go ahead and change some stuff to improper fractions so we can write it as a top and a bottom. So 7 times 5 is 35. 35 plus 4 is going to be 39. So we'll have 39 over 5. And we're going to multiply it by 15, which is 15. Oh, actually, I forgot. 39 is not prime. 39 is 3 times 13. And then if we look at 15, 15 is going to be broken into 5 times 3. And that's 15 over 1, right? So let me go ahead and be consistent here with everything. This is 39 over 5. And this 15 here is going to be 15 over 1, okay? So there you have everything as prime factors. Let's see what cancels out. This 5 and 5 cancel out, and I think that's it. The bottom is just going to be a 1. Nothing too exciting. 3 times 13, we know is 39. And 39 times 3, well, 40 times 3 is 120. Take away a 3, that's going to be 117, I think. So let's do 117 over 1, or just 117. Cool. If we were to go about this cross-canceling, this is what, 39 over 5, I think we said? 39 over 5, and we're multiplying that by 15. Then again, you could just cross-cancel the 5 and 15, divide them both by 5 to get 1 and 3. And then I think that's it. You would just multiply this 39 by 3 and get 117, and 1 times 1 on bottom is 1. And then we can just write that as a whole number. There we go. Okay, hopefully after a few practice problems, you're getting the hang of this skill and you're feeling a little bit more comfortable with this strategy. Okay, let's move on to number 17. 17 is where we're going to start dividing fractions. And so let's give that a try. For number 17, let's see. 17, we have 15 over 7. And we're dividing this by 8 over 21. So when we divide fractions, we actually will rewrite it as a multiplication problem. And that's kind of like the algorithm we like using here. So I like to say keep, change, flip. So we always keep the first one. We change the division sign to multiplication sign, and we flip it. So it's not KFC like Kentucky Fried Chicken, but it's KCF. So maybe Kentucky Chicken Fried? I don't know. However you want to think about it. Some people say keep, change, flip. Some people say multiply by the reciprocal, because technically when you flip it, that flipped version is considered a reciprocal. Whatever works for you is perfectly fine. So again, it turns out that you can solve any division problem of fractions by just keeping the first fraction and then multiplying the reciprocal of the second, or the flipped version of the second. So we just flip it upside down. Okay, So I'm actually not going to write the prime factorizations out anymore. I'm just going to use the cross-canceling method. And so let's see what common things that we see. So I will go ahead and write it as like one fraction. I'll write 21, 15 times 21 and 7 times 8. Sometimes that's a little bit more clear of what's going on for people. And so 7 and 21 can be both divided by 7, and we get 1 and 3. And I'm trying to think if there's anything else that I see here, and I don't think so. I think that might be it. So let's see, 15 times this 3 is going to be 45. And then on bottom, 1 times 8 is just going to equal 8. Okay, let's see. Let me move this over so I can fit everything. 8 goes into 45. 6 times is too much. It's got to be a little less than 6. How about 5? 5 times 8 is 40. So it goes in 5 times with 5 left over. So 5 and 5/8. I think that makes sense. Oops. Got it. I guess it doesn't have to be perfect, but I've already been doing it for every problem, you know? Okay, so there you go. That would be the division or the quotient of this problem here. That would be the answer, okay? For 18, maybe I'll go an extra space. Why not space it out more? For 18, we have 18 over 35. And we're dividing that by 24 over 42. Okay, so 18 over 35. We're going to keep this first one. Let me go ahead and write that again. It helps. Sometimes it helps just rewriting it. Keep, change, flip. And so we have 18 over 35. We're going to multiply this by the reciprocal, which is 42 over 24. Rewriting as one fraction, we have 18 times 42. And that's on top of 35 times 24. So we don't have the prime factors here, but that's okay. We're just going to go ahead and see what common things we see. And so this divides by 7, and this divides by 7. We'll get 6, and we'll get 5. This divides by 6 to get 3, and this divides by 6 to get 4. 6 and 4 can both divide by 2, and we get 3 and 2. So 3 times 3 on top is going to equal 9. And then 5 times 2 on bottom is going to equal 10. So 9/10 would be the quotient here, or the answer to the division problem. So 24/42 fits into 18/35, 9/10 of a time. So it's slightly bigger than it. Most of it fits in at least one time, or one time exactly, but 90% of it. So let's see, 19, we have 4, we have 4 divided by 12 over 15. So again, we're going to keep this one the same, then change, then flip this one. So 4 as a fraction is just going to be 4. What is going on there? 4 as a fraction is going to be 4 over 1. And then that's going to change division to multiplication and flip this one upside down. It's going to be 15 over 12. Okay? So now it's just a multiplication problem. So if you were worried about dividing fractions, it's actually not too bad as long as you keep, change, flip. It just becomes a multiplication problem. Okay? Cross-canceling 4 and 12, divide them both by 4, we get 1 and we get 3. And then 15 and 3 can both divide by 3 to get 5 and 1. So we have 1 times 5 on top, and that's going to be 5. And on bottom we have 1 times 1, which is going to equal 1. And so 5 is our final quotient. Okay? This just means that 12/15 fits inside of 4 5 whole times. Exactly. Let's see, question 20. We have 15 over 13, and we're going to divide that by 10 over 13. So we're going to keep this, change this, and flip this. Again, same process, just getting some practice down. The more you do it, the easier it gets. 15 over 13, change this to multiplication and reciprocate this, so it's 13 over 10. Now it's a multiplication problem, okay? So we have 15 times 13 on top, and then we have 13 times 10 on bottom. Oh, this will be super nice. Okay, 13 and 13 cross-cancel to make 1 and 1. And 15 and 10, you can divide them both by 5 to get 3 and get 2. So 3 times 1 on top is going to be 3. 1 times 2 on bottom is going to be 2. And we can say this is 1 and 1/2. There you go. All right. couple more examples together for dividing fractions. Let's try question 21. And 21 is going to be 3 2/5. And we're going to divide that by 1 1/10. Okay, so as an improper fraction, 3 times 5 is 15. 15 plus 2 is going to be 17. So we have 17 over 5. And let's see. Maybe I'll write out an extra step here. So if we go ahead and do that, I'm just going to keep it as a division problem. So 1 times 10 is 10. 10 plus 1 is 11. So that's going to be 11 over 10. So here you can notice it's still a division problem. I just had to take one extra step, or we have to take an extra step to change it to improper fractions. Okay, so keep, change, flip. And so if we rewrite this as a multiplication problem, because we haven't done that yet, that's 17 over 5 times 10 over 11, right? And so maybe I won't write it as one fraction. I think maybe you're getting the hang of it, hopefully. It's the same deal, but this and this both divide by 5 to get 1, then 2. So then if we multiply our leftover values here, 17 times 2 is going to be equal to 34. And then 1 times 11 here is going to be 11. And so 11 goes into 34 3 times with 1 left over. All right, that's 33, and then with 1 left over. So here's 21, okay? Here's 22. 22 looks like we would have 4 3/4 divided by 2/3. And so let's rewrite this as some improper fraction. So 4 times 4 is 16, plus 3 is going to be 19. So that'll be 19 over 4. And let's divide that by the other fraction of 2/3. Wait, we don't have to do anything. That's already a proper fraction. All right, cool. So we're going to keep this, change this, flip this. And if we do that, we end up with 19 over 4 times, again, we're going to flip this one upside down, so it's going to be 3 over 2. So I know it's super sad, but we can't cross anything out here, so we're just going to have to multiply 19 times 3, that's 57. And then on the bottom, 4 times 2, that's going to equal 8. Let's see, 8 goes into 57 7 times. 7 times 8 is 56. So it goes in 7 times with 1 left over. So 7 1/8. That is the last division problem from this section, okay? So we have a couple word problems now, some applications, so let me help walk you through that. Let me see how much space we got. Yeah, let's go on to the next page here. 23. Let's see, the length of a rectangle is 4 2/3 centimeters, and the width is, determine the area in square centimeters. Okay, so let me sketch out a rectangle. I guess it's closer in size. The dimensions are pretty similar. So let's do 4 2/3. That's the longer one, and then 3 1/2 is the shorter one. So I know in the first few problems we're talking about perimeter, and that's where you add fractions up together, add the sides. But area for a rectangle, let's try to keep in mind area is going to be length times width, or base times height, however you want to think about it. So I'm going to call this my length. I'm going to call this one my width. And so let me just highlight those to make it super clear. Try to be consistent. So this will be the length, and we're going to multiply that by the width. And so the width is going to be here. Okay, so let's make a substitution in. The area is equal to 4 2/3. And let's multiply that by 3 1/2. Okay, that would get us the area. So good thing we know how to multiply fractions. But 4 times 3 is 12, plus 2 is going to be 14. So this is going to be 14 over 3. And then if we take a look at 3 1/2, 3 times 2 is 6, plus 1 is 7. So just keep in mind we're changing things to improper fractions. And unfortunately, I don't see any cross-canceling that we can do. Oh, sorry, actually, I spoke too soon. 2 and 14, divide both by 2, we get 7 and 1. So if we simplify now, then we don't have to later. So 7 times 7, that's going to equal the 49 that we get from multiplying those together. And then 3 times 1 is going to be 3. So kind of all over the place here. I guess I'll continue this over here. And let's see, let's divide 49 by 3. I'll write it out just because I haven't in a while, but 3 goes into this once. 1 times 3 is 3. That's going to be 1, remainder of 9. Let's see, 6 times 3 is 18, and so a remainder is 1. If you knew 16 times 3 was 48, wonderful. I'm just trying to write it out to help people. And so that's going to be 16 and 1/3. And I think we have centimeters squared, right? Square centimeters. That would be the area of this rectangle if those were the dimensions. Okay, there's 23. Next we have 24. 24, slightly different problem. Let's see here. It's actually interesting. We're given that the length is 2 1/7. So I'm going to put that here, 2 1/7. And we're given that the area is equal to 18 2/3. So this is the width right over here, and we don't know the length over here, or actually they call it the length. So let me try to be consistent there. It doesn't really matter. Let's call this the length. Let me rewrite that, the length, and this will be the width. So again, it doesn't matter which one's which. Sometimes I know it's a little confusing. You're taught the length is always a longer side. It doesn't matter though. Okay, so length times width or width times length, you're still going to get the area. So we know the formula for area of a rectangle. Area is going to be length times width, right? So we can say the area is going to be 18 2/3, and they tell us the length is 2 1/7, and that has to multiply by something. I'll put the width here, and let me just use some colors to kind of organize everything. So the length we're given, I think I used this color for the length last time. So this is the length, and this is the length, right? Length times the width. We don't know the width. It's our unknown. We're trying to figure that out. And all of this is going to equal the area. So again, the area is something we were given this time, and that's over here. And so that's all of those colors labeled similarly. So if we know 2 1/7 times something equals 18 2/3, then we should be able to say, right, that the width is going to equal 18 2/3 divided by 2 1/7. Right? So if we know that like length times width equals area, then area divided by length should equal width. Okay, so it's like saying if we know 3 times 5 is 15, then 15 divided by 3 is equal to 5. The only thing is in this case, we're looking for the unknown. We're not sure off the top of our head our 2 1/7 times tables, right? So let's see if we can figure this out. Turning into improper fraction, 18 times 3, that's 54 plus 2, that's going to be 56. So 56 over 3, and we're going to divide that by 2 times 7 is 14 plus 1 is 15, so that's going to be 15 over 7. Okay, then we need to keep, change, flip, and if we keep, change, flip, that's going to be 56 over 3 times, and we're going to write 7 over 15. So this looks like a bit of a bummer. I don't think there are any factors of 56 that match with 3 or 15. I'm going through my divisibility rules, and 7's prime and 3's prime, so that doesn't help us either. So I know this is a little bit annoying because we can't cross cancel. 56 times 7 should be 350 plus 42, 392. 392 over, and then 3 times 15 is going to be 45. So let's see. 360 would be, I think, 8 times this goes in. I think 8 times 45 is 360, so it goes in 8 whole times. That's 360. And we have 32 left over. So 32 over 45. And so that, I think, would be the width of this rectangle. That would be in inches. So almost 9 inches, but a little less than that. It's going to be 8 inches. Let me just double check that real quick. I'm being a little stubborn and not writing out the work. I know 9 times 4 is 36, so 90 times 4 is 360. 45 is half of 90, so it goes in 8 times. That's 360. Yeah. That should make sense. Cool. And that is those are all the homework problems that you had to do. Okay, let me go ahead and try showing you some of those challenge problems now, in case you were interested in giving those a go. Again, this is totally something from Algebra 1, but if you're interested in knowing about it, then stay tuned here. So it's going to be x over 5 times 11x over 4, and let's multiply that by 10. I can make these a little darker. 10 over x to the 5th power. So these are actually quite nice to go ahead and do. We can actually cross cancel right from the beginning, or we can multiply the numerators together. I'm actually going to make it one fraction and multiply the numerators together. So we'll just start by multiplying 11 times 10 on top. So we'll multiply 11 times 10. Those are the coefficients and the constant numbers up there. And so that's going to be 110. Okay. And then let's see. We can multiply this x times x together, and that's going to be x squared. Okay. On the bottom, if we multiply those numbers together, we have 5 times 4, and that's going to be 20. So we can say this is 20. And then we are just left with this x to the 5th power on bottom, and that will be x to the 5th power. So this is like if we multiply first and then simplify second. In a little bit, I can show you like another strategy for a different problem, but I won't do every problem twice here, okay? I'm going to divide these both by 10, and that's a nice, easy thing to do there. And then I'm also going to cancel out 2 of these x's with 2 here. So if we take away 2 x's as factors on both top and bottom, we still have 3 on the bottom. So finally, we will say that our answer here, our product is going to be 11 over 2x to the 3rd power. That would be as simplified or Simpleefyed, we could write this expression. Okay. Again, that's one way to do it. There are other ways I'll show you in the future problems. I'm just not going to do them all multiple times here. Okay. So that's 25. I'll do 26 right over here, I think. I think that gives enough space here. 26, we got what, 16x over 7 being multiplied by 35x cubed over 8x. Okay, so in this case, let's try to simplify before we multiply. Okay, I think, again, that's kind of the way that most people will do it eventually. And so if you can hang with this, that'd be awesome. And if you can't, it's okay. You can multiply, then simplify. So divide these both by 7, that's 1 and 5. And divide these both by 8, and that's going to be 2, and that's going to be 1. We can also cancel out like one of these x's here. We get rid of that. That's a little confusing, actually. Cancel out this 1x with this 1x up here, so those are gone. And I think we have nothing left on top and bottom that's similar. So we have this 2 and 5, that makes 10. And then we have this x cubed left on top, so that's x cubed. And on the bottom, we have 1 times 1 left, which is just going to be 1. So our final expression is going to be 10x to the 3rd power. Darn it. This would be, there we go. Okay, so this is a much simpler way of showing the same thing. So no matter what x is, if you plugged in any value for x to the original expression or plugged in that same value to this one, you'll get the same product. Okay, let's check out 27. This one looks a little scarier. 27, we have negative 5d to the 5th power, and that's over 14. And we're going to multiply this by 21d. And that's going to be 10, whoops, I don't know what's going on with my pen here. It's acting up. 10c to the 3rd power. Let me see. Yeah. And then divided by negative 28d to the 3rd power over c to the 8th power. Okay, I think I got it all. All right, so we're gonna change this a little bit the best we can so that we can just have one long multiplication sentence. So we can keep this, change this, and flip this. So we just have one long multiplication problem. So again, we're gonna keep this. I'm just gonna copy and paste this. So let's see, we'll have this. And then we're just going to multiply by the reciprocal or the flipped version of this last fraction. And so that's going to be c to the 8th on top, and then 28d to the 3rd on the bottom. Okay, hopefully that's not going to be cut off the screen later. Okay, so now we have one long multiplication sentence, and that's kind of nice. We can now maybe do some cross-canceling here. So we do have a negative and a negative here. Do you guys hopefully see that? So a negative times a negative is a positive, so we don't have to worry about those. So that's kind of nice about signs. And then 14 and 21, we can divide them both by 7 to get 2 and 3. And for the 5 and 10 here, we can divide the 5 and 10 both by 5 to get 1 and 2. Notice how cross-canceling gets a little crazy here with the amount of things going on. Now that we're done with numbers, maybe they'll change colors to for the C's. There's 3 C's on the bottom and there's 8 on top. So if we cancel them out, there's still going to be 5 on top and none left on bottom. And let me go to a different color for the D's. For the D's, let's see. These 3 down here can cancel out with 3 of them up here, so this one will be left with 2. I think that is everything. This is a bit of a mess though, right? Let me see if I can keep track of everything here. I think for coefficients, we just had 1 and 3 on top, so I think 3 is the only coefficient we need on top. And then what about the C's here? I think we have c to the 5th we don't want to lose track of, so c to the 5th power is left. And what else do we have? D's. For the D's, we have d to the 2nd power times d to the 1st power, so that makes d to the 3rd power. And on the bottom, what coefficients do we have? We have 2 times 2, which is 4, and then 4 times 28, which is right over here. That should be 112. So 112. And do we have any letters on the bottom? I don't think so. Let's move that to the middle. And 112 is not divisible by 3 because 1 plus 1 plus 2 is 4. So if I'm not mistaken, and I kept track of everything well, this would be our final answer. 3c to the 5th power times d to the 3rd power over 112. Let me just look it over real quick to make sure I did not make any silly mistakes. I don't think I did. All right, I don't think I made a mistake, but if you think I did, let me know in the comment section down below, and let me know, because I definitely could be making mistakes. Definitely getting a little sleepy here too. So let's see here. For 28, whoever created these problems, these ones are tough to keep track of. Let's see, we have 18a cubed b to the 2nd power all over 4a divided by 27ab to the 7th all over 8a to the 2nd power. And we're multiplying this whole thing by 15a squared b to the 5th all over 2a to the 4th. Okay, so division starts here. We can keep, change, flip. So running out of space there. No worries, I'm gonna keep this one. We're changing this to multiplication. We're gonna flip this one. And so we're gonna put 8a to the 2nd power on top, and we'll put this 27a times b to the 7th on bottom. And we're not really doing anything with this yet, so I'm just gonna copy that down here. Okay, so let the games begin. Let's see what we can cancel out here and keep track of. So let's do our very, very best to be as neat as possible. Maybe I'll scribble some stuff out as I go too, a little better. So I'm gonna start with this 4 and 8. So if you divide them both by 4, it's gonna be a 1 on bottom and a 2 on top. I'm not gonna write the 1 because 1 times everything stays the same. Actually, this 2 and this 2 cancel out completely, so those become 1s. Let's see what else we got here. Where do I want to go next? I'll stick with numbers, I guess. 18 and 27, they'll both divide by 9. So that would be a 2, and divide this by 9, and that would be 3. Okay. If you need to rewind, go for it. But I'm gonna stick with this because it's a little bit more clear for me. 3 and 15 can both divide by 3, so the 3 becomes a 1. You don't need to write it. That becomes a 5 up here. And if I'm not mistaken, that's our only value, or coefficient rather, that we have left here. So let me go ahead and put this 5 on top. Okay, so I'm done with the 5s. Let's actually move on to maybe the A's now. So let's see. There's one A down here I'm getting rid of. Whoopsies, I don't know what's going on with that. Whoops. All right, whatever. Well, that A is canceled out. With this one, let's make 2 A's I'm crossing out on the bottom. So I crossed out 2 A's on the bottom, and I'm crossing out this A to the second power on top. So I crossed out 2 A's on the bottom and 2 A's on top. That's fair. Then I will cross out 2 A's on top and 2 on bottom, so this makes 2 left. Then I'm going to get rid of both of these down here so that we only have 1 left on top. Okay, that takes care of the A's. I just realized that this shouldn't be a 5, this should be a 10. Yep. All right, so I'm just kind of, again, keeping track. This is kind of the puzzle of it. And let's see what we have left. We do have an A as well, right? I think I'm good. Let's see. On the top, we have 2 B's and 5 B's. That makes 7 B's in total, right? And that means we can cross that off with the 7 B's on the bottom. Oh, well, then is our final expression just 10A? That whole mess just simplifies down to 10A. Alrighty, I'm convinced. Let's move on to these last couple problems. Let's say we have 29 here. 29, oh goodness, we have addition and subtraction. It's back. The common denominators, let's see. Okay, that minus A over 3 minus 2A over 2. All right, so we need common denominators here. I'm thinking 2 goes into 4, so don't worry about that. I'm thinking maybe 12. 12 works for 4, 3, and 2, but not 7. What about 28? 84? I'm not sure. Okay, let's see. Maybe I can use the ladder method here. 7, 4, 3, 2. Sorry about the sirens if you hear them. Hopefully everything's okay. 1, 7, 4, 3, 2. And let's see what goes into just 3 of them. Nothing goes into just 3 of them, I don't think, so that takes care of that. 7, 4, 3, 2. And then now that nothing goes into 3 of them, let's check to see what goes into just 2 of them. And I think 2 goes into 4 and 2, so that's 7, 2, 3, 1. And I think everything's relatively prime with each other. So if we go ahead and multiply these outsides, we get 2, that's 14, that's 28. 28 times 3 is 84. So I think 84 is the first time they meet, right? So this will have to multiply by 12 to get there. This has to multiply by 12 to get to 84. This should multiply by 21. This should multiply by 21. To get to 84, this should multiply by 28. And 28, and to get to 84, this one should multiply by 44. Or no, 42. Sorry. To get to 84 is what we're trying to get to, right? Times 42. So at this point, we can move our negatives to the tops if we like, right? So I'll make this negative 36A. Again, everything's going to be over 84. So I'm just going to write everything on top of 84. So we have negative 36A. That takes care of this part here. And then for 2A times 21, that should be plus 42A. And then for this negative A times 28, that should just be minus 28A. And then for this minus 2A times 42, that should be minus 84a. Okay, that should be all over 84 since now they have common denominators. So let's see here. The top all has a value, so negative 36 plus 42, that's just 42 minus 36, that should be 6. 6 minus 28, or 28 minus 6, that's negative 22. Negative 22 minus 84, I think that should be negative 106, if I'm not mistaken. Negative 106a over 84. Okay, yeah, I think that's right so far, and I think we can maybe simplify this. SimpLEEfied divided by 2, 53 over 42, and I think they're relatively prime. So I'm going to use their GCF. I believe their GCF is 2 here. I'm not going to write out the ladder method. I'm pretty sure 53 is nothing in common with 42. So divide by 2, half of 106 is 53. That's a prime number. And half of 84 is 42. So while 42 has factors, 53 doesn't have any common factors with it. And so that would be our solution. And one final problem. Let's go ahead and try number 30 here. We have 4x, and that's going to be over 4 minus x over 2. And by the way, for these, I know there's more than one way to do them. So if you did them a different way and still got the right answer, wonderful. Okay, all power to you. 3x over 6. Okay, so common denominator, this one might be easier to come up with. I'm thinking 12 works for 3 of them except for 9, 18 works for all of them except for 4, 24 works for all of them except for 9, 36 is probably the first time, right? Yeah, I think 36 is going to be the LCD. So this will be times 9, this is times 9, times 18 times 18, times 4 times 4, and then times 6 and times 6. All right, let's see here. So 4x times 9. Well, actually, let me go ahead and write the common denominator. We came up with 36, right? So 36 is what they can all go into. So again, this 4x times 9, that's going to be 36x. And then this is minus 18x. Okay? And then this is going to be plus, what is going on there? Something's weird's happening with my pen. I don't know if it's a Bluetooth thing. Plus, oh my gosh. No, what's going on? I'm going to try again. Okay, all right. 4 times 5, that's 20, so it's going to be plus 20x. Again, the x is just kind of come around for the ride. Nothing too special. Don't overthink it. It's just multiplying the pieces together. And this is negative 3 times 6, so minus 18x. All right, so just trying to center this a little bit. And so on the top, 36 minus 18, that's 18, right? And then 18 plus 20 is 38. And 38 minus 18 is back to 20. So this whole thing should just kind of simplify down to saying this is 20x over 36. And if you divide them by their GCF of 4, we should get the most simplified expression, which is just 5x over 9. And there you have it. I believe this is the most simplified expression you can have for number 30. Again, if I told you what x was, if x was 7, just say, you could plug in 7 to the original expression and solve it, or you could just plug in 7 here once into this expression, and I guarantee you will get the same thing if we did this correctly. All right, so these are all the problems for Unit 8 Homework 1. I hope, or Unit 1 Homework 8, sorry, and I hope it was helpful so you can see and hear and kind of go along with the thought process. So feel free to use this as a resource in the future to help bolster your understanding the best that you can. And so just going back here, what did we have? This was the homework. These are all the questions. And if you need to practice any of them, they're at the top. And then you have a detailed key kind of here on everything. So there you have all of these practice problems from start to finish. And feel free to use it as you need. All right, good luck.